promised geometric interpretation. First of all, x of t equal cosine omega t, y of t equals 2 sine omega t simply defines an ellipse in the xy plane, and the ellipse has major axis of 2, semi-major axis of 2 in the y direction, and a minor axis of 1 in the x direction. I generally teach people to sketch an ellipse by sketching a rectangle and then inscribing the ellipse in the rectangle. I'm going to let you imagine that rectangle and imagine that I'm really making these lines tangent to the sides. And I'm kind of missing. I kind of missed there intentionally to not run through my 1, but we see that that's an ellipse. So that x and y follow a path around this ellipse. And one revolution around the ellipse in a time interval of 2 pi. Now f of xy equals x squared plus y cubed. How does that expression change as we move around this ellipse? Well, first place, we notice that x is never bigger than 1, so x squared is never bigger than 1. X squared is only 1 at t equals 0 and t equals pi, and then x decreases, and as x approaches 0, x squared approaches 0 rather quickly, more quickly than x does. By the time we get up to this point, y is equal to 2. Well, 2 cubed is 8. So we can write down just a few sample values of this function. At this point, x is 1 and y is 0, so that z, didn't leave myself a lot of room there, did I? Z equals 1. Here, had to write that pretty small. Up here, z equals 8. And down here, since x is being squared, of course, z is back down to 1. And down here, y will be, well, this is negative 2 down here, so that z is going to be negative 2 cubed, which is negative 8. So we can imagine a motion around this ellipse as a base, starting out at a height z equals 1, moving up in some fashion to z equals 8, and then back down to z equals 1, and then down to z equals negative 8, and I can't demonstrate that because I can't go through the table, and then back up to z equals 1. Now we might try to sketch that. Let's go ahead and construct a three-dimensional set of coordinate axes. Our semi-minor axis is in the x direction, and that's 1 unit, and we come over 2 units in the z direction. In order to sketch this, it is probably a good idea to go ahead and sketch some dotted lines through those axis points to construct the rectangle in which to sketch the ellipse in the xy plane. And now I complete the sketch. Trying to keep this ellipse tangent to these lines. That's a little bit wobbly, not a particularly good sketch. And let's locate our z points. Okay, when x equals 1 and y equals 0, then z is 1. So we're going to be up this high. By the time we get over to the point where y is 2 and x is 0, we're going to be up 8 units high. So it's going to be way up here. But then y begins to decrease, and x begins to increase in the negative direction. Since x is squared, though, we're going to somehow come back down to this point. And then by the time we get over here, z is going to be -8, so we're going to be way down, maybe here. Now, how do we get from here up to here, back down to here, back down to here, and back up to here? We can get a lot of information about that by looking at our derivative of f with respect to t. Remember that this revolution takes place as t goes from 0 to 2 pi, this whole cycle. And then the cycle is going to repeat. The x and y values are just going to continue repeating, and the values of the f function are going to continue repeating. Now I'm just going to try to draw something resembling a curve. I know that y is going to go up pretty quickly here. X isn't going to change that much. Y cubed has a graph that's pretty steeply concave up. So I'm thinking that as I move from here around to here, I'm going to go up a little bit at first, then I'm going to go up quite a bit more, and then I'm going to go up even more. And I think my graph is going to look something like this, where we understand that these points are kind of curling around the surface of a elliptical cylinder that lies above this ellipse. Now once it gets here, then y is going to start decreasing again, and that's going to give us a rather sharp decrease here that's going to kind of level off as we get down here, and I think that the function is going to kind of behave like this, probably sort of coming to a point up here. We'll see if that holds. Then the y cubed is going to become negative, and we're going to move around the ellipse, and as we curl around the ellipse, we're going to move rather sharply downward, and then we're going to come up again rather sharply and curve back here. So there's kind of a sketch. Each one of these points lies above or below the ellipse.